Hello everyone. In this video, I am going to explain reflection of light. As we know that we are not able to see any object in dark room. But as the light will incident and the reflected light from the objects received by the eye, then we are able to see object. It means light makes the things visible. Now reflection of light. Whenever a ray of light will be incident on a surface and it will bounce back in the same medium with the same speed, then this phenomena is called reflection of light. Here, an incident ray will incident on a plane mirror and it will be reflected back. So, this is called reflection of light. In this diagram, incident ray, reflected ray, and normal at the point of incidence are shown. Now the laws of reflection of light. So there are 2 points. First one, angle of incidence, which is represented by I, is always equal to angle of reflection. In this diagram, R will be the angle of reflection. So we can write angle I is equal to angle R. Now in second point, incident ray, the normal to the mirror at the point of incidence and the reflected ray all lie in the same plane. So you can see in this diagram, all are in the same plane. This is the plane in which all three will be there. Incident ray, normal and the reflected ray. Now the formation of image by plane mirror. So let this is plane mirror. An object is placed, then some ray coming from the object will be incident on the plane mirror and the reflected back. As we produce these rays in vector direction intersect at a point, so we get image. So in this diagram, this is the object and this is the image. Now the properties of image formed by the plane mirror. Image is always virtual and direct. Size of the image is equal to the size of the object. The distance of the image will be equal to the distance of the object from the plane mirror. Means these both the distances are equal. The image formed by the plane mirror will be laterally inverted. Spherical mirrors. So these are the part of the sphere. There are 2 types. First one is concave, a spherical mirror whose reflecting surface is curved inward, that is, faces towards the center of the mirror, is called concave mirror. On the other hand, a spherical mirror whose reflecting surface is curved outwards, that is, faces away from the center of the mirror, is called convex mirror. You can see this is concave mirror and that one convex mirror. These are the reflecting surface in concave mirror. Reflecting surface will be concave and these are the polished surface. So when the outer surface will be polished, then we get concave mirror, and when the inner surface will be polished, then we get convex mirror. Now concave mirror and the terms related with these spherical mirrors. So in first diagram, there is a concave mirror and in second diagram, there is a convex mirror. So first we will define pole. It is the center of the mirror, denoted by capital P. Now, center of curvature. So, the center of the sphere by which we will form a spherical mirror known as center of curvature, denoted by capital C. So, these are center of curvatures. Now, radius of curvature. It is the distance between center of curvature and the pole. So in this diagram, the separation between C and P, known as radius of curvature, it is denoted by capital R. Principal axis. A line joining the center of curvature and the pole of the mirror is called principal axis. So in these diagrams, XP will be principal axis. Now focus. Other is incident parallel to the principal axis after reflection passing through a point lies on the principal axis known as principal focus. You can see in this diagram, these are the rays which are incident parallel after reflection passing through the point. This is the point. It is known as focus or principal focus. Now, similarly, in convex mirror, all the rays incident parallel to the principal axis after reflection appears coming from the point lies on the principal axis known as principal focus. So these are the parallel rays. Now they appears coming from this point. So this is known as principal focus, denoted by capital F. Focal length, the separation between pole and the focus known as focal length. So in both the diagrams, PF will represent focal length denoted by small f. The relation between the radius of curvature and the focal length is R is equals to 2f. So we can say the twice of the focal length will be equal to the radius of the curvature. Aperture. It is the diameter of the reflecting surface. Note that it is not the diameter of the sphere from which the mirror is cut out. Now the rules for the image formation. If two or more than two rays will intersect at any point or appears to intersect, then we get image. There are two types of the images, real and virtual. When two rays or more than two rays actually intersect to each other, then we get real image. When these rays appears to intersect, then we get virtual image. Remember, real image is inverted. On the other hand, virtual image will be erect. So this is the first rule for the image formation. All the rays incident parallel to the principal axis in concave mirror after reflection passing through the principal focus. So this is the incident ray. After reflection, it will passes through the focus. This is normal. If we want to draw normal at the point of incidence, then we join the point of incidence with center of curvature. So this is angle of incidence and this is angle of reflection. Now this diagram for convex mirror. In convex mirror, all the rays incident parallel to principal axis after reflection appears coming from the principal focus. Now second rule. A ray of light incident from the direction of the focus after reflection passing parallel to the principal axis. In convex mirror, a ray traveling towards the direction of the focus You can see in this diagram, this is the ray going towards the principal focus. After reflection, it will be parallel to the principal axis. Now, third rule. A ray incident from the direction of the center of curvature retrace their own path. So this is the ray incident from the direction of the center of curvature retrace their own path. Similarly, in convex mirror, there is a ray traveling towards the direction of the center of curvature retrace their own path. जहां से आएगी वहीं return हो जाएगी. Now, fourth and last rule for the image formation. A ray incident at the pole, making some angle with the principal axis, reflected back at the same angle with the principal axis. It is also an convex mirror. So these are four rules. Out of these four rules, to get the image, we consider minimum two rays. Remember, in all the cases, laws of reflection of light are applicable. Image formation by concave mirror. There are 6 cases in concave mirror. In first one, when the object is placed at infinity. So let this is the concave mirror. Object will be at infinity. So all the rays incident parallel. So they intersect at the focus. So we get image at the focus. It is real and inverted and very small in size, highly diminished. In second case, when the object is placed beyond C. So in this diagram, an object AO is placed beyond C. So first ray we consider incident parallel to the principal axis. After reflection, it will passes through the focus. And second ray incident from the direction of center of curvature retrace their own path. So these rays will intersect between C and F. So there will be the image, which is between C and F, real, inverted, small in size. Now third case, when the object is placed at C. So this is the object placed at C. A ray incident parallel to the principal axis after reflection passing through the focus, and another ray incident from the direction of the focus reflected parallel to the principal axis. So we get image at the same point, means C. This is image. It is also real and inverted and same size. Now fourth case, when the object is placed between C and F. This is the object placed between C and F. A ray incident parallel to the principal axis after reflection passing through the focus, and second one, incident from the direction center of curvature retrace their own path. So this is the image, which is beyond C. Enlarged image will be there, real and inverted. Now fifth case, when the object is placed at the focus. So this is the object which is placed at the focus. So first ray incident parallel to the principal axis after reflection passing through the focus, and second one we consider from the direction of center of curvature. Remember, in this case, both the reflected ray will be parallel to each other. So these rays meet at infinity. So the image will be at infinity, which is real, inverted, and enlarged. Now in last case, when the object is placed between pole and the focus. So this is the object which is placed between focus and the pole. First ray incident parallel to the principal axis after reflection passing through the focus, and second one incident from the direction of center of curvature retrace their own path. Remember, these rays cannot actually intersect, but when we produce these rays in backward direction, so they appears to intersect at this point. So we get image behind the mirror. So this is only the case in which we get virtual image in concave mirror. The image will be virtual and direct and enlarged and behind the mirror. The summary is, when the object is at infinity, image will be at focus, highly diminished, real and inverted. When the object beyond C, image between F and C, diminished, real and inverted. When the object at C, image is also at C, same size, real and inverted. When the object is between F and C, image beyond C, enlarged, real and inverted. When the object is at focus, image will be at infinity, highly enlarged, real and inverted. Finally, when the object is between P and F, the image behind the mirror, enlarged, virtual and erect. So these are the different cases in concave mirror. Now the image formation by the convex mirror. So this is the convex mirror, and this is an object placed in front of it. So first ray incident parallel to the principal axis after reflection appears coming from the focus, and second ray incident towards the direction of the center of curvature retrace their own path. So these rays will appear to intersect between P and F at that point. So there will be the image. It is virtual and erect, smaller in size. So one more case is there, when the object is placed at infinity, the image will form at focus. So there are only two cases in convex mirror. Now the uses of concave mirror. Concave mirror are used in torch, searchlight, and headlights of the vehicles as a reflector. They are used as a shaving mirror. They are used by the dentist to see large images of the teeth. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Now the uses of convex mirror. Convex mirrors are used as a rear view mirror in the vehicles as they form diminished images, so the large object on the road can be seen on the mirror. They are used as a magic mirrors and to form funny images. Sign convention in mirrors. So according to the sign convention, object always placed towards the left of the mirror, and the pole of the mirror can be considered as a origin. All the distances are measured from the pole of the mirror. Distances measured to the right of the pole along to the positive x-axis are taken as positive, while those measured to the left of the pole along to the negative x-axis are taken as negative. Finally, distances above to the principal axis, means along to the positive direction of y-axis, are taken as positive, and below to the principal axis, that is along to the direction of the negative y-axis, taken as negative. When we solve the numerical problems, we will substitute the values of u, v, f, h, and r according to the proper sign convention. So now, sign convention in this diagram. This is the pole considered like a origin. This is the positive direction of x-axis and that will be the negative direction of x-axis. Above to the principal axis, positive direction of y-axis, and below to the principal axis, negative direction of the y-axis. So when the object will be placed towards the left, so this is the direction of the incident light. When we measure distance towards the left, that will be negative. When we measure distance towards the right, it will be positive. Similarly, height of object, height of image above to the principal axis, positive. Below to the principal axis, considered negative. This one for convex mirror. Remember, focal length of the concave mirror will be negative. On other hand, the focal length of the convex mirror will be positive according to the Cartesian sign convention. Mirror formula. It is the relation between u, v and f. U is used for the distance of the object from the pole of the mirror. V is used for the distance of the image from the pole of mirror, and f known as focal length. This relation, written as 1 by f is equals to 1 by v plus 1 by u. It can be also written out like 1 by v plus 1 by u is equals to 1 by f. Magnification. It is the ratio between the size of the image to the size of the object, denoted by m. So m is equals to h dash divided by h, where h dash height or the size of the image and h will be the size of the object. We can also write magnification in terms of v and u. So in mirror, it is minus v divided by u, denoted by m. So finally we can write m is equals to h dash divided by h is equals to minus v divided by u. So this is the reflection of light. All the topics covered by me in this video. Hope all of you are able to understand all the concept. In next video, I will explain the refraction of light.